So hello everybody and good morning from Sarawak from Borneo. It's already 5:48 a.m. here, yeah. And for your information, it's right now we in Sarawak right now is we are on Wednesday on 22 July 2026, and yes, today is, at least from what I can say, yeah, it's not what I can say, it's reality here. it's it's already Sarawak Day, aka also Sarawak Independence Day for us. So yay! We have already, yeah, since we already got that brief self-governance period before we before we finally not just on the, and also, how do I say, contrary to what many in the, how do I say, historical lessons wants you to believe. It's We are basically in a sense of not only just not only just joining but also forming the Federation of Malaysia at the same time in 1963, just around less less than 2 months after we gained our self-governance, you know, because without it, it's not going to be a Federation of Malaysia. It's not going to exist without Sarawak, Sabah, Peninsular Malaysia, and also at the time before, at and also a brief period of time in 1963 until Singapore got kicked out 1965. That's where the Federation of Malaysia actually exists. So yeah, but anyhow, I'm getting myself way too ahead. It's and it's fine. We are So far we are going to go live pretty soon. So please be a little bit patient. We are going to be getting there. So yeah, keep an eye. We're we're going to go live pretty soon. Okay, so I think we can finally go for live. So let's go with this one, shall we? Okay, so let's go. Let's go, everybody. Okay, just slightly testing, but it should be fine. Yeah. So hello everybody, and good morning once again from Sarawak from Borneo. We are right now at 7:35 a.m. here on Wednesday, 22 June 2026. Okay, just to give you a little bit of context. Okay, and today is also today, at least in my place right now, it's Sarawak Day. Also officially gazetted, how do I say, officially gazetted as a Sarawak Independence Day. So yay. So it's been 63 years for us since gaining that self-governance, and also in the same year also forming and joining this Federation of Malaysia. But that one is a little bit later part, on 16th of September. Yeah, 16th September 1963 at that time as well. So it's basically just a wee less than 2 months after that. But well, is it? Yeah, less than 2 months after that. So I'm just a little bit ahead of the history, but however, it's okay. Okay, that's not really 100% the point. Okay, but the point is that today it's going to be the launch of the SpaceX's. Yeah, so to say I'm getting way a little bit too ahead, but anyhow, today it's going to be the launch of today. I'm Dennis Suguwa, your host today. We are going to watch the SpaceX's Falcon 9 Block 5 rocket launches. They will be carrying the SpaceLogistics. That one is actually subsidiary of Northrop Grumman. Okay, for the MRV MEP. If I yeah MRV MEP. In case you don't know, MRV stands for Mission Robotic Vehicle, and MEP stands for Mission Extension Pods. Okay, for this MRV-1 mission. Okay, this one is basically is the satellite servicing in orbit mission. This one will be targeting to the geostationary transfer orbit at first, and then followed by the geostationary Earth orbit. This one will be used to service. Yeah, this one will be used to service and extends the geostationary Earth orbit satellite useful lifetime of maximum, usually by the maximum of 2,000 kilograms by up to 6 years. Okay, and 2,000 kilograms I'm almost forgot as well, so almost forgot to put in, so I'm going to put in here. Okay, so I should be able to update. Yeah, 2,000 kilograms, or aka around 4,409.25 pounds. Okay, this one will be able to extend by 6 years for this mission as well. Yeah, and we are not going to be too long here, so bear with me a little bit. Okay, as well. And this one, and for the MRV, that one, each of it's going to be a massing of 3,000 kilograms, or around 6,613.87. Yeah, 87 pounds there. Okay, is it good? Okay, all right. So it's actually still good. Okay, so the mass of the MRV, it has 3,000 kilograms, or around 6,613.84. Sorry, 6,613.87 pounds. Okay, and the each of the MEP, it has a mass of 400 kilograms, or around 881.85 pounds. So with the total mass when clustered by 3 together is 1,200 kilograms, or around 2,645.55 pounds. Okay, so when it's merged together for the MRV-1 mission, the total mass gonna be 4,200 kilograms, or around 9,259.45 pounds. And this one will be servicing three GEO satellites, one for Optus and two for Intelsat. So it's going to be attaching it with the MEPs, also by attaching it with MEPs respectively. So, and this is also part of the DARPA's. Okay, DARPA, in case you don't know, is actually the Defense Advanced Research Program agencies. This one is the US DARPA, RSGS, the robotic servicing of geosynchronous satellites. So basically that's it, and we are going to straight up go to the live because I don't have too much time. So yeah, we will be going for sure. Don't worry about this. Let me see. Okay, so give me a little bit of time. We are going to go live here. All right. So we should be good. Is it? Yeah, we should be good. Or are they? Ooh. Okay. That's a little bit of abnormal. on the SpaceX stream, apparently yeah, on the SpaceX website, it's not 100% there, but yeah, but otherwise, here is already completed. Okay, never mind though. I think, I think we still can make do of this one. It's okay. Okay.
Launch director, go for launch.
Okay, launch director
Great
has
news
already
there.
go for
LD is go
launch.
for launch. Let's sit back and watch as Falcon 9 prepares for liftoff. At just over T minus 30 seconds, all systems are go for launch.
T
Okay.
minus 30 seconds.
Minus 30 seconds. Get ready in for the launch.
T minus 15 seconds.
Okay, 15, 14, 13.
T minus 10, 9, 8, 7, 6,
Okay,
5,
4,
3,
3,
2,
2,
1.
1. Ignition of the Falcon 9.
And liftoff.
And
Go
liftoff.
Falcon, go MRV and go MEP.
Yeah, just like they said, liftoff from the Cape Canaveral Space Force Station, from the Space Launch Complex 40, launching of the SpaceX's Falcon 9 Block 5 rocket, carrying the SpaceLogistics's MRV-MEP for the MRV-1 mission. So we have liftoff. Okay, and anyhow, I hope this is a little bit good as well.
Into flight, Falcon 9 has successfully lifted off
Okay,
from Space
so by now
Complex
the
40
roll,
at Cape Canaveral
Geo,
Space
and
Force
pitch
Station.
program has
The vehicle is
should
currently
already
throttling
been
down to
completed by
prepare
now.
for max Q, the point of maximum aerodynamic stress on the rocket.
Power and telemetry nominal.
Okay, power
There's
and telemetry
confirmation
is
from mission control
nominal.
that everything is on track.
Okay.
Max Q is reached when the air density of the atmosphere.
Falcon 9 is supersonic.
Okay, Falcon
and there's
9 is
confirmation that
supersonic.
Falcon 9 is now moving faster than the speed of sound. So again, we are standing by for max Q, which is reached when the air density of the atmosphere decreases faster than the increasing speed of the rocket, and that's why it's a critical milestone for us during flight.
Okay,
max
so
Q.
that's very important.
Right on
okay,
schedule.
max Q.
So now
It's
there are
already
several
reaches
events
max
coming
Q.
up back to back.
Maximum aerodynamic pressure fully exert on the
stage
rocket itself.
separation and
Already
second
done.
engine start, or SES1.
Okay, so it's
MECO
already
is
done.
just what it sounds like. That's the moment when the first stage engine shut down because the booster has done all that was needed to get the second stage.
Okay, so
and
far
payload
it's
to orbit.
already done
MECO
most of its
immediately
job.
proceeds stage separation when the first and second stages are decoupled from each other. After that, the second stage ignites its single Merlin vacuum or
So in case
MVAC engine
you
for
want
the
to know
first time.
why it
MVAC
looks
in flight chill.
Yeah. So in
There
case
we
you
heard
want
we're
to know
beginning to
why
chill that MVAC engine for ignition up in space.
Okay. So in case you want to know why it looks a little bit like orange-ish color here, yeah, with the dark
Awesome
Sugis
views
there,
as
is
we take
because
our
it's
mission
actually
robotic
burning
vehicle
the
and MEPs to orbit.
it's actually
We are
burning
standing
the
by for main engine
the
cutoff
super refined
just under
kerosene.
30 seconds from now.
Okay. With the liquid oxygen when it's mixing, of course it's going to produce something like this. So pretty logical.
And for those of you following along at home, you do have in the bottom corner of your screen a good readout of our current speed and altitude telemetry, as well as an indicator of which engines are currently lit on board our first stage.
So far so good.
MECO.
Okay, main engine cut off. Should be on the first stage. Oh, no, still not yet. Okay, with main engine cut off.
Stage separation confirmed.
Okay, stage separation already confirmed.
Confirmation of main engine cutoff and stage separation. Great views
ignition.
of both of those, and of course MVAC ignition on board our second stage as well.
It has already cut off around
next is fairing
74, 73 kilometers of the altitude, and get ready in for the pilot frame separation. Get ready.
More great views of that MVAC engine burning up in space as we take our payloads to orbit today.
All right. Okay. Okay, so we are still getting ready in for the pilot frame separation. Yeah, by now, should be payload frame separation.
Fairing separation confirmed.
Okay, here we go from the inside view.
There we have a
Okay,
great
payload frame
visual of fairing
separation is already
separation and, of course,
confirmed.
our announcement from Mission Control.
Okay,
So those two fairing halves are now making their way back to Earth to hopefully be recovered again. And coming up next is SECO-1, the first shutdown of the Merlin vacuum engine on board our second
yeah.
stage, which is
And
expected
this
at
one is
about
not
T plus 8 minutes,
recoverable for
followed
now,
by
so
SES-2, when the Merlin vacuum engine on
so
that second stage
unfortunately,
is going to
it is what it
relight.
is.
We're going to take a short break, and we'll see you back here just before SECO-1.
Okay, so fortunately, because they already currently doing their break, so yeah. So in the meantime, I have something to yeah. So I have also something that I can correct in the meantime. Be- Okay, and so sorry as well for the technical problem. Okay, it's not something that we like to do, but when it happens, it happens. But anyhow, this one is much cleaner. Should be good. Okay, so well. Yeah, how do you like that? How do you like that? So this one is much better. Yeah, I'm sorry, I can't even properly solve the technical problem that we have. Okay, but all is good, all is good. And look at that. Yeah, look at that. Finally. Okay, so let me adjust this as well again. Okay, should be fine. Okay, that should be fine. Yeah. So thank you so much for your patience. We already done our best. Okay. So here you go on the velocity. So again, you need to remember that the booster involved in this flight, the first stage booster involved in this flight, the B1062, it already it already reaches its limit right now. So this is the 32 32 final flight. So unfortunately, it's already reaches its usefulness. But anyhow, it's already okay. It is what it is, and we should be getting ready in for the Seco one. But however, it's all okay though. Here you can see it's still burning the super refined kerosene there. Okay, RP1. Okay, but it is what it is. You can see we are almost reaching to the initial low Earth orbit velocities there. But anyhow, it's still good. Still can do its job. And the altitude right now is a little bit dipping right now, but that's pretty nominal because yeah, to the 161 kilometers and then later on 160 kilometers. That one is pretty nominal. It's because of the Oberth orbital mechanic law that dictates how you can actually also launch it to the certain amount of the orbit using as less energy as much as less energy and propellant as much as possible while maximizing the heights that you can go. So that's why the orbital velocities looks like that. Okay, the velocities looks like a little bit deeper lower, 24,600 kilometers per hour and going up. Altitude is still dipping, 158 kilometers, but it should be fine. And the g-force is 3.3 g's. Okay, 3.4 g's. Okay, and the Merlin vacuum still, or vacuum Merlin still ignite.
I'm sorry, SECO-1.
Here we go.
MVAC shutdown.
And we have
There we
Merlin
have
vacuum engine
confirmation that
shut
MVAC
down.
has shut down for the
So
first
it
time
has
on
already
today's
done its
mission.
job. So pretty good.
Nominal orbit insertion.
Okay, nominal
And
orbit
confirmation from
insertion.
Mission Control that we are
So
in a good
that's
orbit.
already a very good indication we like to hear so far.
The next milestone we're waiting for is second
Okay.
engine start 2, when our MVAC engine on board the second stage will relight. That's set to occur at t plus 28 minutes and 52 seconds. So we're going to take another break here to stretch our legs and leave you with some more great views and space tunes.
Okay, so we already have done as well, but at least on the SpaceX side, they have already done their production there. And yeah, and also earlier on, I'm a little bit sorry if you see a bit of technical issue pretty much a bit earlier, but otherwise the streams looks pretty healthy and fine, and that's what actually matters the most. Okay, so so yeah, so basically my basic troubleshooting what I do, it's actually pretty simple. What I do is that I just I just close whatever SpaceX related website that I actually open up, if even on my second monitor that I've already hooked in. That one is actually I'm using the Samsung Galaxy Tab S10 FE. Yeah, I'm actually connected using the space desk. Okay, so that's why, no wonder why it does it, why the live stream didn't work. So we should take note of this next time. So whatever is it, as long as it still work, why not? But anyhow, this is the mission. It's still costing t plus 10 minutes into the flight. Everything looks good. And yeah, I can also say that I guess it's also better for me to just how do I say, I think it's better for me to just try and compensate for my for my lack thereof technical problem. It's okay. Okay, so for this one, let me see. Is it actually okay though if I go like this one? What about this one? Maybe I can try. Ooh. Okay. Okay. I'm actually just looking at if I could actually technically put this into the picture mode, but well, it's not. Yeah, there's no option there for now, so it's okay. While it's still costing, maybe I'm also going to give a little bit of the information as well, how the mission's going and whatnot. So just to make life a little bit easier, let me go. And yeah, I'm also pretty sorry as well if I do look a little bit of unprepared, even though I tried my best, but things happen from time to time. It's cropping, but it's pretty normal. Okay. Anyhow, we are still still costing into the flight. So MRV-1. Okay. So we are going to see at T plus 29 minutes, we are going to see the SES2, aka the second stage engine start number 2. We are going to see that soon after especially after a few minutes ago of the Seco 1, aka the second stage engine cutoff number 1. So on at the T plus 7 minutes and 55 seconds into the flight. Okay, and then after that, yeah, for the second relight of the engine itself, it's going to last around 1 minute and 5 seconds into the flight. Okay, on which the second stage engine cutoff number 2, Seco 2 will occur at T plus 30 minutes and 5 seconds into the flight. Okay, and then afterward, this will be a little bit progression. Each 10 minutes in, each 10 minutes in on at T plus 35 minutes and 34 seconds, it's going to be MRV-1 deployment, and then followed by another 10 minutes at T plus 45 minutes and 34 seconds, it will be MEP-1 deployment, and then later on another 10 minutes ahead, T plus 55 minutes and 34 seconds, it's going to be MEP-2 deployment, and then finally at T plus 1 hour 5 minutes and 34 seconds, it's going to be MEP MEP3 deployment. So that's basically in the nutshell how the mission actually goes by. Okay, so it's actually kinda good. Yeah. And yeah, to actually compensate for my little bit screw up here, maybe I'm going to let you know. Okay, each of these. Okay, agreed. So this is it from the NASA space flight website as well, in case you wanna watch here. Okay. Ooh, that's actually kinda stretch up, isn't it? You see. As well. Okay. But it's okay. We are going to put it, let me see here. Okay. So in the meantime, we are still waiting. Okay. Hold on a little bit for a second. Okay. So it should be something like this. Okay. Here we go. Is it? Okay. Oh, that's a little bit weird as well in terms of my own preparation, but it's fine. Okay. But anyhow, rather than wasting too much time trying to fix the weird technical problem, okay, so here we go, I guess. Yeah, so here we go. The best. Actually, you know what? Yeah, so this is the best that I can do. So, bear with me. This is the okay. So this is the best that I can do. Here you go. The MRV seats with 3 MEPs, obviously one for Optus and Intelsat for 2. It's basically some agreement. So this is how it's going to look like if it's going to attach. Okay, it looks something like this. Okay, and another one as well is here. Okay, so this is how the turnkey point actually how it looks like. Okay, you can see when the MEP is actually inserted together, it's going to extend the lifetime of the satellite usefulness itself. Okay, so this is how it's basically going to. So the MRVs, the mission robotic vehicle, it's going to insert the MEPs, the the mission extension port at the back side of the satellites. You know, it's going to insert around the thruster area of the planned serviced GEO satellites. There, it's going to go inside, basically refuel the propellants of the GEO satellites itself, and it's going to, and it should be able to properly extend that lifetime by up to 6 years. Could be a little bit more if the total mass of the GEO satellite itself is even much more smaller. So that's basically it. And another one here as well. Okay, so this is also as well how it's going to do its stuff here. You can see how the missions, and also from my side here, you can see this is how it's going to do its job when capturing things here and there. And then another one here as well. Okay, and also this is how it looks like when they actually go and service all of this stuff. You can see the technician actually inspect all of the robotic arm here for the MRV, so it can properly attach this MEPs to these affected satellites that need some kinds of operation there. Okay, and here we go. And then if we go here again, okay, I'm going to allow here. It's okay. Yeah, so this is how it looks like. Even the planning is already years ahead. Okay, you can see how the servicing looks like. It's going to be like this. Okay, attached together. This one inside the clean room integration, payload integration. So you get some of the idea as well. And another one here as well. Oh, okay, we can zoom in. It's okay, no worries though. Okay, so this is how it looks like on the attachment as well of the MRVs. Okay, and we are going to continue, and this is still going to do their job again. Okay, another one here and there, and rather than bore you too much down, you can see how the integration looks like. Okay, you can see the integration there. Also inside the clean room, but this one is to with this one is also to do. Oh, yeah. Sorry, it's not for the with. It's actually not for the propellant fueling. This one is rather being used to do some kind of vacuum chamber testing, so they are able to see whether or not everything else is working of the payload itself. Okay, and this one as well. Okay, you can see this is how they actually conducted their test. In case anything's not working, at least they know. Yeah, I'm correct. That one is for the thermal vacuum lab test. Okay, so this is how they are going to assess whether or not it's going to work properly or not. Okay, and let me see again. Here we go. Okay, so another one as well. It's working here and there. Okay, so on orbit, it should actually go with this one. Okay, this is how it actually does the mission. It's going to attach directly inside of the propellant thruster. MRV, it's guiding in the MEP. Okay, you can see there it extends its own fueling line there, going attached inside it, filling it in until it's already full, and then the mission should be working as well. Okay, and we are still looking in. Okay, so and also just like some of you very interested as well, MVP is sort of like the small propulsion jetpacks, sort of like that. So this is actually very good analogies how we like to call MEPs. Okay, and another article here as well. Okay, so you can see actually I attach it, and yeah, that's also how it works as well. And other than that, I think we should be okay. Yeah, should be okay. And that's basically the rest of the mission. So yeah, we've already done. And yeah, we are going to discuss a little bit about the MRV-1. Okay, in case you don't know about this. Okay, so the MRV-1. So no wonder. Let me. Can I actually technically make it work here? Technically, just. Oh, okay. I think we should be enough. Yeah, I think we should be enough here. Okay. Here and there. Okay. Should be enough. Okay, okay. So yeah, keep in mind I'm still tweaking this a little bit here and there. Okay, so here we go. We are still doing some things here and there. Pretty normal. That's literally also how do I do some kind of servicing here and there. I mean, it happens from time to time. Okay. Okay. So what from what I can tell, this should be quite fine there. Okay. So it should be quite fine. Okay. So that's basically it. We've already solved the problem. So thank you so much. Thank you so much for being a little bit patient and being a little bit detailed as well, trying to solve it, even though it's inside the OBS. But it's okay. Okay. Anyhow, this is the MRV-1, the patch itself. Yeah. So thank you so much to the Gunter Space patch here. Yeah, special for providing the resources here, because without it, it's going to be knife to very impossible trying to go and show you how it looks like here. So yeah. So basically this is it, how it looks like. Okay, this one is it uses the Geostar 3 satellite bus. Okay, this one is actually built by the Northrop Grumman, specifically the Northrop Grumman Innovation Systems, and before that it's actually used to be Orbital ATK, and then even before that it's actually Orbital Science. Yeah, just in case you want to know, this one built together by it, and also with the US Naval Research Laboratory as well. So for the payload side, so basically it is what it is, and it should have a lifetime of 15 years. But well, we are going to look at it if they are going to launch more of it. But whatever. This one is the MRV part, the mission robotic vehicle, in case you want to know. This one developed for the RSGS, for the robotic servicing of geosynchronous satellite. Okay, and this one is for the MEP. Okay, you can see there. Let me see. Yeah, the closer we get, the weirder it can be. But anyhow, you still can see here, as I'm still crediting here. Okay, this one is the MVP, the mission extension pods. How it looks like, very small satellite as well. But most of the information we don't know. But this one is also built only by the Northrop Grumman Innovation System only. Okay, and another one as well. Okay, this is their official website. Okay, but anyhow, rather than bore you too much, we are going to go straight to the live coverage, and here we go.
In partnership with DARPA. 3 pods
Okay.
are launching alongside the MRV today, which will be the nation's first multi-mission robotic servicer in space.
So we are going to see
it's
that
capable
soon
of
as well.
repairing, relocating, inspecting, upgrading, and servicing other satellites with 2 robotic arms,
Okay,
which were
and soon
provided
enough
by
at
DARPA
the
and
plus
built by the U.S.
29
Naval
minutes,
Research
we are
Lab.
going to see the mission.
22,000 miles above the Earth in geosynchronous orbit,
Okay.
MRV will use those robotic
All
arms to
right.
attach mission extension
So that
pods,
should be
or
good.
MEPs for short, which are basically mini jetpacks designed to extend the life of satellites running low on fuel, helping them to maneuver and extend their service life by up to 8 years.
Yeah, as you can
MRV
hear, that's
MEP will
basically
carry
how
out
the mission,
operational
how
missions for
it's
national
actually
security,
function.
civil, and commercial space customers.
Okay, so we are getting ready in for the ignition.
We're standing by with just about 15 seconds until SES2.
Okay, so
Once
should be ready.
MVAC relights, we are expecting this burn to last just over 1 minute.
Okay. Okay, we will hear this one ignition soon. But by now on the timeline it has already ignited. Okay, because mind you, there's always going to be some kinds of latency here and there. And here we go. Should be for the second stage engine start number 2 already start ignite. Let's go. And as you can see there,
You can see on your screen we have had
the
successful
vacuum Merlin engines there,
SES2 for our
due to the
MVAC
ignition
engine.
and also due to the, how do I say, the combustion and burning of the super refined kerosene, the RP1, rocket propellant one. You can see the complex hydrocarbon chain there. When it burns, it's going to produce this reddish orangish color there.
You can always follow
And
along with
also
how our stages are doing with your telemetry in the
there's
bottom
literally
left-hand corner of your screen. And you can
Earth
also see the
atmosphere
G-force currently
to
being
keep
experienced by
keep the
stage 2 in that
as the
G-force
pressure
counter
to
on the
keep the
right-hand side.
shape of the rocket exhaust flame there to keep it
Just about 10
stro
seconds left in this burn.
straight inside the how do I say, inside the nozzle there. That's why they have to design it. They have to design it wider, bigger, and larger of this vacuum Merlin there. So that's why it needs to extend. And that's it. It has already done its job. The second stage engine cutoff number 2, or visually already confirmed, but we will hear
Nominal
the.
orbit insertion 2.
Okay, so nominal
There's Mission Control
orbit
announcing that we
insertion
have a
2,
good
so
orbit.
already
And
done
with
its
that, the
job.
Northrop MRV-MEP is well on its way to orbit.
Okay, it's well
Now, as a reminder, we won't be showing
on
any
its
deployment views
orbit.
today
Okay.
at the request of our customer. So that will bring us to the end of our live mission coverage. We'd like to thank Northrop Grumman for entrusting us with
So
their
they've already
spacecraft
ended the
today.
stream.
And we'd
All
also
right.
like to thank the FAA and Eastern Range for their support of today's mission.
All
Be
right.
sure to check out spacex.com/launches for the most up-to-date information on upcoming missions, and follow us
Okay,
at
so that's all.
SpaceX
So
on
they've
X.
already
See you next time.
ended the stream. Oh man, it's okay. But anyhow, thank you for watching in. Okay, it's fine. At least I can go sleep by now. But before that, yeah, and before that, let me also as well going to show you another bit here as well. I'm going to show you here by by the full screen here. Let me see. Okay, I'm going to close the tab from the SpaceX already done its job. Okay, so this is it. And for the MRV, in case you're very interested, this is how it looks like. And there's even like a very specific spreadsheet there about how the missions going to look like. Okay, this one is for the MRV, the mission robotic vehicles. Okay, and yeah, and this one is actually extended from the previous MEV, if I remember correctly, from the mission extension vehicle. Okay, so of course it's going to include the detailed robotic inspection, augmentation, relocation, repair, refueling, and also docking with non-standard client basically aka other satellites provider, how they actually operates in the first place. Yeah, I forgot to open the music, but it's okay. Okay, and also you can see what it features. It features the 3 meters long of the 7 degrees of freedom of the robotic arms. You can see here as well, and apparently it has 20 plus situational camera awareness cameras. Okay, for the safe robotic operations as well. Apparently also with the single fault tolerant MEV MEV bus designs, refuelable chemical propulsion systems for our pod. Okay, our pod is rendezvous, proximity operations and docking, in case you want to know, and also for the electric propulsion for orbital maneuvering. Okay, so it's basically it in the nutshell. And another one, if we actually look at the MEP, okay, mission extension port. So this is how it looks like. Okay, similarly, this one all in together, and as you can see, okay, so the features here, basically so it can extend. It's not 6 but actually 8, so I was corrected there. I'm going to correct myself on the stream, I mean on the description. So here and there, we're going to do that. Yeah, we're going to do that later on. And basically it uses the electric ion propulsion using the xenon as the propellant. And basically that's it. Not much else to say here as well. Another one should be here. Yeah, but anyhow, MEV is not necessarily needed, but if you still want to read here's the MEV, how it looks like. Okay, it's because it actually extends from this. You can see what's the benefits here and there. So that's why I said there's not much else on this spreadsheet, but otherwise it is what it is. And yeah, in case you also want to know, probably I'm going to give a little bit of briefing here as well. Okay, in case you want to know, okay, the Merlin 1D and its vacuum derivative, it actually uses the gas generator cycles, okay, where basically the gas generator cycles in the nutshell, the fuel and oxidizer propellant, it's actually burned together inside the pre-burner. This one uses just a small amount of it just to move this turbine together for this fuel and also the oxidizer, so it can goes down to the some of it. Most of it is going to go inside the combustion chamber, inside the nozzle, and then expel out. But some of it can be dependent. It can either uses the oxidizer or the fuel, and also some of it around the small portion of it, but still significant. It's going to go around the nozzle and also around the nozzle and combustion chamber there to cool down the cooling wall jacket of it, so it's not going to melt itself, and then it's going to go inside back to the combustion chamber and then going out, and it should be good. And the rest of it, of the pre-burner, after it moves the turbine, it's going to go to the small exhaust piping there where it's the operation's already done. And basically that's how the gas generator cycles work. In this case, how the Merlin 1D and the vacuum Merlin variant also works. So that's basically it. And if you want to see how the operation works, it's going to be something like this page. Okay, so as you can see, this one actually how the operation works on the, let me see, open cycle the gas generator. You can see how it works visually similarly like I described, and you can see small piping of the pre-burner, okay, and then exhaust out from the small exhaust there, and the rest of it going to the combustion chamber, and the rest of it, and some of it also goes to the cooling wall jacket of the nozzles and also combustion chamber before eventually inserted back into the combustion chamber itself, burns out, and then that's basically it. Operation in the nutshell. So yeah, I think I've already done my job here. Okay, so is it? Yeah, so we've already done the job. Okay, this one will be for next stream as well, here and there, and I'm going to show, let me see here. Okay, so we've already done our stream today. So yeah, thank you so much for watching, even though this is quite brief, but it's okay as well. And yeah, it's not the most perfect thing that I've already done, but consider this stream is more like a chill stream here and there. Yeah, and basically that's it. We we are going to see soon at around 10:50 a.m. here on local time here. Okay, but before that, but let's just say if if international rocket launches manage to go live for, let's just say, or maybe let's just say I'm able to find the live stream to these launches of the Gravity 1 Flight 3. For this mission, it's the Gravity 1, the serial flight number is Y4. If we are able to see, we are going to watch as well. And yeah, you can say this rocket is actually pretty small. In terms of the height, it's actually 29.4 meters, and the diameter, I I can say, if we combine even the strap on together, it's going to be 4.2 meters. 3 stages apparently. Okay, so we are going to see that, and hopefully I'm able to give you the stream here and there. So Kim and I, we are going to watch that soon. So yeah, we already done. And yeah, thank you so much everybody for watching. I really appreciate that you have already come to the stream, even though my stream is not really the best on the best shape so far, but whatever. Just treat this a little bit like a chill stream, and also some kinds of troubleshooting stream as well. I don't know. Maybe you can treat it as such, because I'm still working out some of the kinks, but it's okay. And anyhow, thank you so much everybody for watching. Stay safe and take care. I'm Daniel Suguwa, your host today for the launch of the SpaceX's Falcon 9 Block 5 rocket carrying the Space Logistics. That one is the subsidiary of Northrop Grumman's. Yeah, Northrop Grumman. Okay, for the MRV-MEP mission, for the MRV-1 mission. So we've already saw it. At least initially, everything looks fine, looks good. But anyhow, it's should be okay as well. But thank you so much everybody for watching, and take care, stay safe, bye bye. Yeah, and also I'm going to take myself a bit of rest here and there before going for another stream here. So thank you so much everybody for watching, stay safe and take care, bye bye. And I'm also going to put in the timestamp as well for the launch procedure. So thank you so much, we'll be back soon. And that's it, we've already done, already finished. So take care, bye bye, stay safe.